Hello, and thank you so much for attending this workshop today, where you and I are going to look at ways that we can incorporate some biological sciences into our classroom science ed curriculum. Many of the NGSS standards are going to be addressed, both in science and in mathematics. And your kids are going to guide most of their learning through this storyline. Please let me know how things go. I'd love to get some feedback. Thank you so much and enjoy. Welcome to the grade 3 to 5 life science storyline. It's really all about environment and survival. This unit is going to provide guidance for best practices in science ed. Additionally, trying to help young students better understand organisms. This project is funded by the BioFab Educational Workforce Development Grant, and it was done under the supervision of the University of New Hampshire. Let's look at a performance expectation from the NGSS standards. The students are going to use their data from an experiment to argue for the conditions that best support yeast growth. This is a second performance expectation specifying specific goals for students of grades 3 to 5. In our unit on the environment and survival, students are working through an experimental design that's going to assist them in all future science experiments and also help them to become better criticizers of theirs and others' experiments. As science educators, we want to be sure to integrate math standards into our units of study whenever we can. We want to strongly encourage students to use numerical data whenever possible. Our unit that we're going to be looking at provides kids with experiences using and testing environmental conditions for the growth and the survival of baker's yeast. Students experiment with yeast environments and determine how one or more conditions can affect the growth of the yeast. These are instructional strategies, routines that have been developed by Open Science Ed, and they ensure for all high-quality learning experiences. We are going to follow these routines as we walk through our unit on environment and survival. The anchoring phenomena is meant to be, a kickoff activity. Our intention is to push the kids to share what they believe to be true. It's also going to act as a formative assessment as it presents the instructor with a precursory understanding of what kids know. So we're going to look for some representation of what the students are thinking. Those can be in drawing form, it could be a written form, it could be a speaking explanation, but the end results are that we're going to share our beliefs with the rest of the class, and we form an initial classroom thinking. Well, let's look at this unit on environment and survival of the very small organism called yeast. What we're looking at are typical results of bread making. Students may have made bread with an adult or certainly eaten some bread that looks like both of the examples in the picture. When we give the kids time to consider those images, or alternatively, we can actually give them some true examples for them to examine. Breads that one on the left with larger holes and one on the right with less large holes, kind of flat and brown. we want to ask kids to share their questions and wonderings about, well, what happened to these breads? Which one would you rather eat? Why would you rather eat that bread? And why is there such a difference in the appearance of those two loaves? With this anchoring phenomena, we're asking kids to draw models of what they think happened between the two loaves, and then, using their ideas and their wonderings, we're going to create something called a driving question board. There are no wrong answers when we're making our observations. Everybody's input is valued, and everybody's input is considered. Development of the DQB. It's like a way for us to create a classroom notebook page. The wonderings, the questions that kids have help us to make sense of the different breads in this example, and it augments the ways to figure out what caused the differences in their breads. The way I've done it is I've used a large sheet of chart paper. At the top, I typically would write the unit name, and I would then record all the questions the kids have on sticky notes, or if the teacher needs to facilitate the recording of the questions for the students, that's totally appropriate too. The driving question board is going to stay up and posted throughout the entire unit. There's a lot of times through the rest of the unit when we might go back to it and see if we've learned some of the answers to the questions we initiated. Now we're rolling into the next section of the routines, the science ed routines. And basically what we're doing here is we're looking at navigating through the unit and investigating. And we're going to fluidly move between both of these routines at this time. We're going to use the questions about the phenomena to drive some investigations. We're going to go deeper. We're going to use science and engineering practices to figure out the science of what is going on. We're going to use the science and ideas discovered and agreed upon to help answer additional questions by designing additional investigations. The navigation routine is all about linking learning across lessons and activities. We're going to show them by navigating. Students should be revisiting their initial ideas that are on the DBQ and focus questions that were recorded there as well. They should be going back to their naive models. Maybe they need to add to those models or drawings they may have done just to revise their thinking. After a few activities, students should collectively build what is known as a consensus model to display publicly in their classroom. And at any point, students and the teacher can go back and forth to the driving question board to answer questions, add new questions, or refine their questions. Let's take a look at how this investigation process might happen. We're going to start with an observational lab. We're going to look at a bunch of breads, and we're going to try to generalize to say, oh, what do all those breads have in common? So as we continue to advance through the unit, each experience should add more, build more to their understanding of the organism of yeast and how it survives best in certain environments. We're going to try to do that by developing a summary board to keep track of what we're figuring out. Well, here's a very common summary board, summary chart, you name it. It's used to keep track of what we have figured out in our investigations. at the very beginning, we're just examining breads with a hand lens. That would be what would be recorded in that top left white rectangle. By examining the breads with the hand lens, we want to ask, well, what did we see? What did we observe? We might be able to figure out something about all breads. It could be something like all breads seem to have some system of bubbles in them. We might want to record things such as, why do some breads have very small bubbles? Other breads have clearly defined and rather large bubbles. What's the difference? Here's a real easy activity, keeping those hand lenses handy, to help kids figure out what causes all the bubbles in bread. 3 bags would be provided to each small group. Bag 1, just water and sugar. Bag 2, we could put water and yeast. Bag 3, let's put in water, sugar, and yeast. All of the amounts are listed clearly in the activity packet that accompanies this unit. And after a couple of hours, and the kids have taken notes, recorded their notes on what's going on in all 3 of those baggies, we're going to have a discussion. We want to get them to begin to discuss the fact that the yeast, in fact, is an organism that is alive, and that, in fact, it's an organism that is alive and eating and creating a gas from the process of digestion. The elementary age student is really a perfect age for kids to begin imagining all that they can't see. So we offer another partial model for the students to examine what yeast is and how it works. The hand lens cannot be used because you can't really ever see the organism of a yeast, a baker's yeast. But we can begin to ask about other better known organisms, invisible organisms, and how their environment affects their survival. A natural progression may lead you to this lesson in the storyline, centering around specific discussions about how temperature, which happens to be a measurable environmental concern, may affect the yeast's ability to digest the sugars and create the bubbles that are found in our breads. Here comes the fun. We're going to work with our students, have them break off into pairs or small groups, and each pair or small group is going to be charged with creating a fair experiment that might help us determine how temperature can affect yeast growth. This lesson is going to take a few days in and of itself. The kids are going to have to contemplate all kinds of variables that they're going to need to think about. Providing them with the time and good discussion opportunities assures that we're going to get some reliable results. Here are some good considerations that your students may have about experimenting with yeast, sugar, and water. Things like, is this how scientists do experiments? Or what supplies might we need for the experiment? Another thing they may be wondering about is, well, are we actually killing something with this experiment? Good questions to add to the mix when you're talking about experimental designs. It would be things like, should we all measure exactly the same thing in order to get results that we can compare? Or how are we going to measure our results? And is timing important to get results that we can rely on? Questions like this will be generated, and you have to be ready for them. Here's an example of an investigation that I watched getting set up. You can see all of the jars are identical in size. I can tell you that they used exactly the same amount of baker's yeast in each jar, the same amount of sugar in each jar, the same amount of water in each jar, but the difference was what the temperature of the water was. One great question that would need to be answered when the kids are looking at something like this: how are you going to measure the differences between each of the results? And one of the best ways the kids that I taught came up with was that they were going to measure the height of the foam in each jar. That seemed to be a way that they could measure the results. And so they did. And in fact, they got some pretty great results from that. There are many different ways to measure results from this experiment. Okay, our next job is to put the pieces together as suggested in the routine chart. We're going to have a lot of different ideas developed, and we need to understand how they're connected. We started off with an initial anchor phenomena and a driving question board, but throughout this unit, we want to engage in argument from evidence we have at our disposal. We want the kids to develop and use accurate models, and we want them to construct explanations based on their evidence and begin to reinforce what is and what is not reliable evidence. We need to get back to that storyline and evaluate our results for our experiments. We need to ask some questions that are going to help kids understand if their results are reliable and significant. We want to steer them towards creating fair tests that can help us make conclusions about the environment and the ability of the yeast to survive. Additionally, it's most common that kids are going to complete their initial investigation and they're going to want to redefine their variables, do some more testing, some different experimentation. If you have the time and the materials, let it happen. One of the last routines we're going to look at is problematizing. We're going to see where we sit with all of what we've learned, and are we at the point where we can explain a phenomena, or do we need to do more and develop different understanding? The teacher presents an aspect that poses a problem. It's new, it's related, but it's not exactly what we've been looking at. So it might mean that investigations have to continue. We try to engage our class at this point to help develop a new and improved consensus model, an explanation that's going to account for all that we're learning about. As the storyline comes to a close, we want to make sure we can make some final conclusions about the environment and the survival of all living organisms, not just yeast. Start within the temperature and yeast realm and then spin it out to include other organisms and answer the question posed in this lesson. Is there an environment well suited for some organisms but ill suited for others? Let's be very specific and begin to generalize what attribute the organisms must have to survive in this environment. An example would be gills for all underwater forms of life, and lungs for organisms that are going to survive on dry land. Finally, let's use our learning to extend with some well-posed questions about other organisms. Let's see if we can conclude how specific attributes of an organism can help it survive. You can use the examples provided here or come up with some of your own. Do let me know if you have any comments or questions about this storyline. And finally, I just want to wish you great luck in developing strong science storylines for all your students.